Check one. Check one. Check one. Hurry. Right. Good evening, all. Exam is over. Second term exam is over. Today we are starting the third term section. Third term of grade 10 starts with third term of grade 10 starts with hydrostatic pressure. So today we are starting hydrostatics. Before that, a small note. Listen, before that, a small note. Now we are in grade 10 third term. Almost you are touched to grade 11. No? Grade 10 third means you have touched to grade 11. You have only one more year for the final exam. Hinda, now don't keep packing your work. Now until grade 9 you did it. No. Now until today you did it. No. You started packing the work. No. Now don't do it. Talk to any grade 11 person and see. That fellow's best advice will be in your grade 10 itself, study and finish off those sections. Don't keep it until the last moment. Now only 2 terms over. No. 2 terms works, now study, finish it off. Don't pack it. If you start to pack now, even though whatever the lessons now are easy, you think, okay, we'll pack it and keep later we can study. That packing will become a huge stress next year. Now don't start packing. Part 1 book is fully over. At least complete your part 1 book within another 1.5 months. Then after that, only part 2 book is there. Okay. So best advice, don't pack now. Try to release whatever the packing that you have already done. Right. Now write down a main heading. Main heading, a third term main heading. Hydrostatic pressure. Hydrostatic pressure. Main headings, hydrostatic pressure. Hydrostatic pressure. Unit 15. Unit 15, hydrostatic pressure. Meanwhile, online Lamai, quickly tell me, I'll open the group. Can you all see the board properly and hear properly? Online people, go to the group. I have opened the group now. Can you hear, no? Because it's heavily raining here. Can, hurry, right. Right. Now listen very carefully. Listen very carefully. Under hydrostatic pressure, keep the hydrostatic part aside. First of all, you should know what is pressure. You can't do hydrostatic pressure. No? First of all, you should understand what is this pressure. Write down a subheading, pressure. Write down a subheading, pressure. Subheading, pressure. Work. Subheading, pressure. Right. Listen very carefully. Listen very carefully. What is pressure? Amount of force acting in a unit area is pressure. What is pressure? Amount of force acting in a unit area. In simple terms, force acting in a unit area. Pressure. Again, what is pressure? Force acting in a unit area. Memorize it in the simplest form. Later, you can design it to a complex form. Amount of force acting in a unit area. You can design it later. Simply, what is pressure? Force acting in a unit area. Again, what is pressure? Again, what is pressure? Force acting in a unit area. Right. We can represent this using an equation. Listen. We can represent this using an equation. What is pressure? Force acting in a unit area. Force acting in a unit area. There you go. Force acting in a unit area. You divide by area. You divide by area. Got the point there? Simplest equation. Later I will design this equation more complex. Simply, what is pressure? Force acting in a unit area. But this force should be a perpendicular force. What kind of a force? Perpendicular force. Now maths. What is perpendicular means? What is perpendicular? 90 degrees. There you go. Line A perpendicular to line B. Line A and line B are making 90 degrees. Then we say line A perpendicular to line B. Same way, this force should be perpendicular to the area. This be perpendicular to the area. So if I redesign this equation, pressure is equal to perpendicular force divided by area. Got the point there? Perpendicular force divided by area. If I show you all, now this is an area. Force is acting. This is a perpendicular force. This force divided by area, that will give us the pressure. Now tell me, is this a perpendicular force? No. Is this a perpendicular force? No. Those are not perpendicular forces. Perpendicular again, with the area, there should be 90 degrees. Perpendicular force. Okay. Understood the point there? Right. Under pressure, write down, put star and write. Amount of force acting in a unit area is defined as pressure. Next point. This can be represented. By the following equation. This can be represented by the following equation. Write the equation, box it. Equation and box it. Quickly, pressure equal perpendicular force over area. Right, now listen. What's the unit used to measure pressure? Listen. What's the unit used to measure pressure? My units don't go to memorize. Memorize only the equation and keep. Now, what's the equation of pressure? Perpendicular force over area. Force over area, no? You all tell me, what's the unit of force? What's the unit of force? Newton, capital N, divided by. Area, what's the SI unit of area? Meter squared. SI unit of area, meter squared. Now solve it. N in the denominator, m to the power 2. If I take it on top, m to the power minus 2. Nm to the power minus 2. There you go. That is the unit of pressure. Okay. This is also called as Pascal. PA. Capital P, simple A. Pascal. Okay. Got the point there? Write it. Write the unit. Okay. Right. Next point. Pressure. Is it a vector quantity or a scalar quantity? Remember, pressure is a scalar quantity. What kind of a quantity? Scalar quantity. What type of a quantity? Scale. First of all, tell me what is vector quantity, what is scalar quantity? First tell me that. First tell me what is scalar? Scalar quantity. Has a magnitude only, scalar quantity. Has both magnitude and direction, vector quantity. I have told you all a shortcut also how to memorize. Scalar, vector, alphabet. What comes first? SOV. What comes first? Alphabetical order. S comes first, no? S comes first. V, vector comes second. Scalar has only one thing, magnitude. Vector has two things, magnitude and direction. Scale only one thing, magnitude. Vector has two things, magnitude and direction. Remember, pressure is a scalar quantity. Only a magnitude is there, no direction. Okay, let's write. Take a color pen, put a star and write. Pressure is a scalar quantity. Pressure is a scalar quantity. Online, Lama, is there a problem with video? Pressure is a scalar quantity. No. Hurry. One more point. Shh. What's the relationship between Nm to the power minus 2 and Pascal? Listen, Lamai, 1 Nm to the power minus 2 is exactly equal to 1 Pascal. What? 1 Nm to the power minus 2 is exactly equal to 1 Pascal. Then you all tell me. 2 Nm to the power minus 2, 3 Nm to the power minus 2, 1000 Nm to the power minus 2, 3000 Nm to the power minus 2. Okay, let's write this and box it. This box it. Okay. Right. Now we'll solve some questions. Right. We'll solve some questions. Write there question 1. Question 1. Shh, shh, shh. Question 1. Under that write down. Under that write down. A perpendicular force of a perpendicular force of a perpendicular force of 100 Newton. 100 Newton. Perpendicular force of 100 Newton is acting on an is acting on an is acting on an area of area of 5 meters squared. 5 meters squared. 5 meters squared. Full stop. Continue. Calculate the pressure. Calculate the pressure. Calculate the pressure. Right. First question I will do. Observe how I do. Observe how I do. First we start with the equation. There you go. Pressure. In short form you can write. Pressure equals force divided by area. What is the force? What's the force? 100 Newton. What's the area? 5 meters squared. Some people are patta lazy. Some of you are lazy to write down the unit. Some of you just write 100 divided by 5. Wrong. Lamai, this is physics. These are physical quantities. Physical quantities have a magnitude as well as a unit. Both together is a physical quantity. If you only write down the magnitude, it's a number. It's not a quantity. 100 is a number. 100 Newton is a quantity. 5 is a number. 5 meters squared is a quantity. In physics, we are dealing with quantities. In maths, you deal with numbers. So here, don't only write the number, write also the unit. If you write only the number, it's like half dressed. Don't make them half dressed. Fully dressed. Beautiful people. Hurry. So, what's the value? 100 divided by 5. How much? How much? 20 nm to the power minus 2. Directly we can write down Pascal. 20 Pascal. Okay. Right. Okay. Right. Question 2, your turn. Question 2, your turn. Write down. Question 2, quickly write down. A perpendicular force of a perpendicular force of a perpendicular force of 200 Newton. A perpendicular force of 200 Newton 200 Newton, is acting on an area, is acting on an area, is acting on an area of 0.15 meter squared. 0.15 meter squared. 0.15 meter squared. Full stop, continue. Calculate the pressure acting. Calculate the pressure acting. Calculate the pressure acting. Leave some space. Third question. Third question. Third question. A girl of mass. Shh, shh, shh. A girl of mass. A girl of mass. 50 kg. 50 kg. Is standing on a tile. A girl of mass 50 kg is standing on a tile. Is standing on a tile. Is standing on a tile of area 0.1 meter squared. Of area 0.1 meter squared. Of area 0.1 meter squared. Calculate the pressure acting. Calculate the pressure acting. Calculate the pressure acting on the tile. On the tile. Your turn. Your work. Be careful with third question. I didn't give the force. I have given the mass. Think. Work. Online people send the answer to the group. Online people send the answer to the group. You know. You're new. Boys, done? Online paper, send the answer to the group, man. Right. Shh. I'll discuss the second question. Second question done. I'll discuss the second question. Shh, 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 shh. Pressure equals force divided by area. What is the force there? 200 Newton divided by. What's the area? 0.15 meter squared. Now, some of you are more scared when you all see decimals. You should slowly learn to solve with decimal. Shh. How to solve with decimal? 200 divided by 0.15. No? You jump to decimal here. Same way you jump to decimal. If I jump to decimal, 20,000. Jump to decimal, 15. Now solve 20,000 divided by 15. How much? 24 times here. 3 times. 4 divided by 3. 1. 4 divided by 3. How much? 4, 1, 10, 3. It goes on going. 3, 3, 3. It goes on going. So multiply by 3. 1, 2, 3. 1333.33 Pascal. 1333.33. You all got it? At the 15, 4, 3 zeros. 1333 Pascal. Keeps on going. Third question, anybody done? Third question. Third question, anybody done? Now see, third question. Shh, shh, shh. A girl is standing on a white tile. Mass of the girl is only given. Mass is how much? 50 kilogram. Using mass, can you solve pressure question? No. First of all, you need to find the force acting on the white tile. Tell me, when you stand on a white tile, what is the force acting on the tile? Your weight. Your weight is the force there. 50 kg mass. Then what's the weight? 500 Newton. How did you get it? Weight is equal to mg. Where did you learn this? Your second lesson. Mass is 50 kilogram. Gravitational acceleration 10. From there, what is your weight? 500 Newton. Force is there, area is there. Find pressure. Look. Nothing big. Pressure equals force over area. Force is 500 Newton. Area 0.1 meter squared. What's the pressure? 500 divided by 0.1. Jump a decimal, jump a decimal. How much? 5,000. 5,000 Pascal. That's your answer. Write down the ones who need. Under this write a review. Under this write a review. Here the mass is given. Here the mass is given. Here the mass is given. Therefore, here the mass is given. Therefore, first we need to find the weight. First we need to find the weight. Okay. Right. Question number 4. Question number 4. Question 4, right there. When a pressure of more than 10,000 Pascal, when a pressure of more than 10,000 Pascal, when a pressure of more than 10,000 Pascal acts on a bridge, the bridge will collapse. The bridge will collapse. The bridge will collapse. Full stop, continue. The mass of a car is the mass of a car is 100 kilogram. 100 kilogram. Full stop, continue. Calculate the minimum area. Calculate the minimum area. Calculate the minimum area of the bridge. Of the bridge. Of the bridge. For one car to travel at a time. For one car to travel at a time. For one car to travel at a time. Think, work. Pressure given, mass is given. Not a force. They're asking area. Then first what you need to find? Mass is given now. First what you need to find? Weight of the car. Done? Boys done? Girls? Right, listen, those who are struck, listen. Pressure given, mass given. They're asking area. Lamai, to talk about pressure, you need area and the force. So using mass, can you do anything here? No. First of all, find the force there. Mass of a car is 100 kilogram. Then what should be the weight of the car? 1000. Then what should be the force there? 1000. We'll first write that. Weight of a car is equal to mass into gravitational acceleration. Mass 100 kilogram. Gravitational acceleration 10 ms to the power minus 2. From there, the weight is 1000 Newton. Now you have the force. You have the pressure. What are they asking? Area. Start with the basic equation. Pressure equals force divided by area. What is the pressure? What's the pressure? 10,000 Pascal. What's the force? 1000 Newton. What you need to find? Area. You don't know area. Then what you do? You subject area. If you subject area, now tell me, denominator goes to the top, then top comes to the denominator. Cross multiplication maths can remember. Take area on top, this on bottom. Now do the question. Area is 1000 Newton divided by 10,000 Pascal. What's the area? 1000 or 10,000, how much? 0.1. What's the unit? Meter square. That's your answer. Write down the ones who need. After this onwards, maths, huh? This is not science. Right, question 5. Question 5. Now more practical questions, think and do. Huh? A Jeep has a Jeep has a Jeep has 4 tires. 4 tires. 4 tires. And the contact surface area and the contact surface area and the contact surface area of each tire is of each tire is 0.2 meter squared. 0.2 meter squared. 0.2 meter squared. Each tire. Each tire 0.2. One tire 0.2. Altogether 4 tires are there. So think. The maximum pressure the maximum pressure that the soil can withstand is 16,000 Pascal. Is 16,000 Pascal. First, continue. Calculate the maximum mass. Calculate the maximum mass. Calculate the maximum mass of the jeep. Of the jeep. Of the jeep with passengers. With passengers that can travel. That can travel. That can travel on soil. On soil. That's it. On soil. Full stop. Work. See, one tire, 0.2 meter squared. One thing to think of. Finally, they are asking the mass, not the weight. Another thing to think of. Think and do. Okay. Anybody done? Right. Now reverse. Now all this time, they give the mass, nothing. They give the force, they give the area, they ask for the pressure. Now reverse. Pressure given. some idea about the area given. They're asking reverse. They're asking the mass. Now read and see. Area of each tire 0.2 meter squared. Altogether 4 tires are there. So altogether, what is the contact area? What's the contact area? 0.8 meter squared. How did you get this? 0.2 meter squared for one tire multiplied by 4 tires. Altogether, what's the area? Total area? 0.8 meter squared. Right. See, area there, pressure there. What can you first find? Force. Force is the weight of the jeep. No? If you know weight of the jeep, can't you find the mass? Now work. There you go. Pressure equals force divided by area. Pressure 16,000 Pascal. Force you don't know. That's the weight of the jeep. Total area 0.8 meter squared. If I cross multiply, force equals 16,000 Pascal multiplied by 0.8 meter squared. 16 into 8, how much? 12800 Newton. 12800 Newton. This is the weight of the jeep. Then you all tell me what's the mass of the jeep? What's the mass? 1280. Directly you can write mass is 1280 kilogram. That's your answer. Those who came little bit late, did you all understand this section? Pressure, what is the equation? Force divided by area. You divide the force by area, you get the pressure value. Pressure is measured in Pascal. That's the only thing. Pressure equal force of area. When you divide force by area, you get the pressure value. You get the pressure in Pascal. Okay. That question, anybody still writing? Jeep question? No? We'll do one more question. Question number 5. Sorry, 6, no? Question number 6. Shh. Right there. Mass of following block of wood. Following block of wood. Shh, shh, shh. Following block of wood. Following block of wood. Is 50 kilogram. 60 gram. 60 kilogram. 60 kilogram. 60 kilogram. Right. Keep space to draw the block. Keep space to draw the block. Under that, Roman number 1. Under that, Roman number 1. Calculate the pressure exerted. Calculate the pressure exerted. Calculate the pressure exerted. When phase A, when phase A is kept is kept is kept is kept in contact with the surface. In contact with the surface. When phase A is kept contact with the surface. Roman 2. Calculate the pressure acting. Calculate the pressure acting. Calculate the pressure acting. When phase B when phase B is kept in contact with the surface. Is kept in contact with the surface. Is kept in contact with the surface. Roman 3. Calculate the pressure acting. Calculate the pressure acting. Calculate the pressure acting. When phase C is kept in contact with the surface. Is kept in contact with the surface. Is kept in contact with the surface. So you have single block of wood. Now if you take a block, there are 3 phases. No, actually there are 6 phases. Here we are considering 3 phases. Upper part C phase, front part A phase, this side B phase. Now we are keeping it in different ways. First, we are keeping A in contact with the surface. That means like this. So contact area is there from A. Next, we are keeping B in contact with the surface. That means this way. Now B surface is in contact. Finally, we are keeping C in contact with the surface this way. Then C is in contact. So 3 different contact areas. Will the mass change? That means will the weight change? No. Weight is always same. Areas are changing. Your job is separately find the areas, find the pressure. Work. Draw it first and then start working. Online people can see, this is 1 meter. 2 meter, 3 meter. See. F is always same. A will keep on changing. Phase to phase, A will keep changing. Shall I give a start for those who are stuck? I'll solve the first one. When A is in contact, Lamai, when A is in contact, the area is this area, no? First find me this area and tell me what is that area. Area equals length into breadth. Length 3 meter, breadth 1 meter. What's the area there? 3 meter squared. So this area is 3 meter squared. Mass 60 kg. Then what's the force? What's the force? 60 kg into 10 ms to the power minus 2. What's the force? 600 Newton. Force is there, area is there. Find pressure. Nothing big. Pressure due to surface A is force over area. Force 600 Newton. Area 3 meter squared. How much? 200 Pascal. Nothing big. Do the remaining part also. Boys done? Roman 2, Roman 3 also work. Done. Roman 2 done. Right. Shh. Roman 2, if I work it there. Face B. This part. This part, what's the area? Face B, what's the area? 2 meter into 1 meter, no? 2 meter into 1 meter. How much? 2 meter into 1 meter. Area of B is 2 meter squared. We know the weight won't change, Namai. Even if you turn it whatever the side you want, weight won't change. Mass won't change, weight won't change then. Weight is always 600 Newton. Then pressure equals force divided by area. Pressure from B is force 600 Newton divided by area 2 meter squared. What's the pressure? 300 Pascal. Go to the last one also. Sure. For the first time from that side. Right. Roman 3. Roman 3 is C, no? C is this area. Tell me. 3 meter, 2 meter. What's the area? 3 meter into 2 meter. How much? 6 meter square. Now just by looking, you can tell the pressure. What's the pressure? 100. Pressure equals force over area. Force is 600 Newton. Area 6 meter squared. From there, pressure is 100 Pascal. Okay. Now got all these things. Those who are writing, quickly finish it. Okay. Right. One special point. One special point. Listen. One special point. Shh, shh, shh. Tell me. What's the equation for pressure? Pressure equal force divided by area. Now think. Hurry, hurry. Force divided by area is pressure. Lamai, if we increase the force, numerator increases. Tell me what will happen to the final value. Numerator increased. What will happen to the final value? It will also increase. See, 4 divided by 2, 8 divided by 2, 10 divided by 2, 16 divided by 2. Numerator increased. Tell me what's the final value? 4 divided by 2, 2. 8 divided by 2, 4. 10 divided by 2, 5. 16 divided by 2, 8. Can you see? If we increase the numerator, final value also increases. So if I increase the force, pressure will also increase. Then if I decrease the force, pressure will also decrease. Got the point there? One more point. If I increase the area, division part, divider is increased. If divider is increased, final value will decrease. Opposite connection. When divider is increased, final value will decrease. There you go. Area increased, pressure decrease. Then area decrease, pressure increase. Got the point there? Right. Then y'all tell me, wearing a heel and wearing a flat slipper, which one exerts more pressure to the flow? Wearing a heel, wearing a flat or a bata slipper, which one exerts more pressure to the flow? Guaranteed heel no. Why? Heel leg gattama, area is very less. If area is less, pressure is more. That's why when the ladies walk with a heel on sandy floor, that mark is there on the floor, just like a stamp. So that mark is there. So once when the area decreases, pressure increase, so that mark remains there. You wear a bata slipper and go, no mark, no. That's why to the beach when you go, you wear a bata slipper. You don't wear a heel to a beach, no. You will get sunk inside. So that's why you wear a bata slipper there. So once when you wear a bata slipper, area more, pressure less. You take Jeeps. Why Jeeps have 30 patol tires? What's the reason? Now Jeeps doesn't have very small tires, no. They have more flat, more fat tires. What's the reason? Area big. Why area is made big? Why? Jeeps are mainly made to go off-road. Off-road, mainly these Jeeps can get stuck in the soil. If the pressure is high, it can get stuck in the soil. To minimize that, they make the area of the tire bigger. When the area is made bigger, pressure exerted on the soil is less. If the pressure is less, it won't get stuck in the soil. Got the point there? Understood? Then you all tell me why a road roller has a big flat cylinder. You don't call it a tire. You have a big flat cylinder. What's the reason? What's the reason? What's the reason? Then only you can evenly distribute the pressure to flatten the road. Understood the point there? Got it? Knives. Why does knives have a sharp edge? What's the I'm asking in science term. Why knives have a sharp edge? Sharp edge, area is less. When area is less, pressure is more. When pressure is more, you can easily cut it. Got the point there? So when you reduce the area, you can increase the pressure. If you increase the area, you can decrease the pressure. Got the point there? Now, still some of you are wondering, Anisa, what is this pressure means? Now, mathematically, okay, understood. Physics-wise, okay, understood. Reality, what is the real pressure means? Pressure means something like this, Lamai. When someone squeezes you, you feel high pressure. Someone comes and squeezes. When someone squeezes you, you will feel a pressure. That is pressure concept. Got the another? Now no need to squeeze, no need. Someone coming and squeezing you. That is high pressure. Got the point there? So to the babies, you get mara pressure that then no. Hurry. No need to write this as sentence, but just write it this way and box it. Lamai, can you understand this one? Or should I give it as when force increase, pressure decrease, when force decrease? Should I give it that way? Or can understand this way? Can all can? What is this? Ade, what is this full thing? Force increase, pressure increase, force, pressure, force, sorry, area increase, pressure. Hurry, then you can understand. Write it that way, box it. Just write down special point and write this and keep. Special point, write it. Yeah. Okay. Any doubts on pressure? Pressure concept, any doubts? No? Hurry. Now we can start the lesson. What is our lesson? Hydrostatic pressure. Now we can start hydrostatic pressure. Write down a subheading. Hydrostatic pressure. Subheading. Hydrostatic pressure. Hydrostatic pressure. Right. Listen very carefully. What is hydrostatic pressure? Pressure acting in a fluid is hydrostatic pressure. What is hydrostatic pressure? Pressure acting in a fluid is hydrostatic pressure. For example, let's say this is a water container, listen. Shh. This is a water container. There is water up to here. There is water up to there. I take a point there. Point A. Shh, shh. I take a point there. Point A. There will be a pressure acting at this point. No. That pressure is called as hydrostatic pressure. So pressure acting inside the fluid is hydrostatic pressure. Now, how to mathematically calculate it? There's a very famous equation. I take from the surface to this point the depth as h. The depth is going to be h. Density of water as rho, or the density of liquid rho. Density of liquid, nothing fluid, just write density. This is rho. Huh? What is this letter? What is it? Rho. You put a C like thing and you circle it. Simple G as usual, that is gravitational acceleration. Gravitational acceleration. Shh. Now, how to calculate the hydrostatic pressure at A? Very simple. Hydrostatic pressure at A is equal to the depth there, h, density there, rho, into gravitational acceleration, g. There you go, h, rho, g. How to calculate hydrostatic pressure? H, rho, g. Very famous equation. Got it? Let's write down hydrostatic pressure under that. Under that. The pressure acting, the pressure acting, the pressure acting inside a fluid, the pressure acting inside a fluid, the pressure acting inside a fluid is hydrostatic pressure. Is hydrostatic pressure. Full stop, continue. It is calculated by, it is calculated by, it is calculated by following equation. Calculated by following equation. Under that, draw this and write H rho G boxing. First draw. First draw this, write these things, after that write this.
Okay. Right. Now, now, looking at the equation, tell me if this depth increases, that means H increase, what will happen to hydrostatic pressure? Looking at the equation, tell me what will happen to hydrostatic pressure? This increase, then this also increase. There you go. Hydrostatic pressure also increase. If this depth decrease, then hydrostatic pressure will also decrease. True, no? If you had gone for swimming in a swimming pool, when you swim on the surface, you will feel somewhat squeezed. But when you go deep under the water, you will feel someone is squeezing you more. Have you felt it in a swimming pool? On top, less squeezing feeling. On bottom of the pool, a lot of squeezing feeling. Why? Top, depth is less, hydrostatic pressure is less squeezing feeling. You go to the bottom of the swimming pool, depth is more, hydrostatic pressure is more, you will feel very much squeezed. Understood the point there? Under that, write this and box it also. Okay. Right. Now you might ask me, sir, this normal pressure that we discussed just before and hydrostatic pressure, are they two different things? Both are pressure. Both are a squeezing feeling. Pressure just in the environment is just pressure. Pressure that you feel inside a fluid is hydrostatic pressure. So both are that squeezing feeling. So outside is normal pressure. Inside a fluid is hydrostatic pressure. Then you will tell me, sir, normal pressure equation is force divided by area. Hydrostatic pressure equation is totally different. No? H rho G. No? How come they have two different equations? Both are same now. Both should have the same equation. No? How come they are two different equations? Actually, this is not there in our syllabus. But for the fellows who are thinking, if you are not thinking, don't of it. If you are thinking, this and this equation are two different things, only for those people. Are some people are like that? No, go very deep into the science. They wanted to build up some unnecessary connections in science and think on it. That's how good scientists come up. So some people think, so this is a different equation, this is a different equation. How come both are same thing? Now, only for those people, I will prove and show these two equations are same. Only for those people. Others may theory nathang, you leave it. Because it's totally away from our syllabus. Only for scientific students only I'm doing this part. Okay. Hurry. Pressure is force over area. Hydrostatic pressure is H rho G. How come that connection? See, I will start from this equation and I'll go to that equation. See, I'll start from here. I will go to there. See, pressure is force over area. No, I can modify it and write there is weight over area also. True, no? That previous questions and all. Pressure, weight over area. I can furthermore modify this and write weight is mg over area. Agree? Weight is mg over area. Now, Lamai, we already know density equals mass over volume. Where did you learn this? In grade 6. Density equal mass over volume, can remember? From this, if I subject mass equals density time volume. Correct? No? If I subject mass equals density time volume. This is my first equation. This is my second equation. Pressure equal mass into gravitational acceleration divided by area. Mass equal density time volume. Connecting both of them, if I write down, see, pressure equal mass into gravitational acceleration divided by area. Instead of mass, I can write density time volume. No? True, no? Instead of mass, I can write density time volume. So instead of mass, I will write density times volume times G divided by area. If I furthermore modify it, volume is area times height. No? Volume is area times height. No? Volume is area times height times G divided by area. Now what? Area in numerator, area in denominator cancel out. Pressure is equal to H rho G. Both are same. Okay. So both the equation are same. No need to understand it. But just remember both are telling the same thing. This pressure tells us the pressure in the normal environment. This pressure tells us the pressure in the fluid. Both are a squeezing feeling. Okay. No need to understand this one. Just know that both are same. Okay. Are only those who won't write it and keep. හැබැයි ඉතින් මේක ලියන්න ගිහිල්ලා මේ කොළප්පන් වෙන්න එපා. Only those who want වගේ shape එකේ somewhere in the side right and keep. Right. Now we'll do some questions, no? From this also. From this also we'll do some questions. Previous one, what was the final question number? 6, question 6. Hurry, we'll do some questions. Question 6, no previous one. Now question 7. Question 7, write down. Calculate the hydrostatic pressure. Calculate the hydrostatic pressure. Calculate the hydrostatic pressure. Acting in water. Acting in water. Acting in water. At a depth. At a depth. At a depth. 2 meters from the surface. At a depth 2 meters from the surface. At a depth 2 meters from the surface. Inside brackets, write density of water 1000 kilogram per meter cube. Density of water 1000 kilogram per meter cube. Density of water 1000 kilogram per meter cube. Gravitational acceleration 10 ms to the power minus 2. Gravitational acceleration 10 ms to the power minus 2. Right. See how I work it out. Next question onwards, you all can work. First, you write the equation. Now tell me, hydrostatic pressure. What's the equation? H rho G. H is not height. H is depth from surface to a point. The depth. H, what's the value? 2 meters. Density of water, how much? 1000. Don't half does it, fully does it. 1000 kilogram per meter cube. Gravitational acceleration 10 ms to the power minus 2. H rho G, how much? 2000, 20,000, no? 20,000, you can one shot write it as Pascal. That's the hydrostatic pressure there. 20,000. That's what I was telling. Hurry. Right off. Quickly write down, we'll do one more question there. I don't look and write. You all work. Okay. Question 8, your turn. Calculate the hydrostatic pressure. Calculate the hydrostatic pressure. Calculate the hydrostatic pressure. Calculate the hydrostatic pressure. Acting in a liquid. Acting in a liquid. Acting in a liquid. Of density 300 kilogram per meter cube. Of density 300 kilogram per meter cube. Density 300 kilogram per meter cube. At a depth 3 meters from the surface. At a depth 3 meters from the surface. At a depth 3 meters from the surface. At brackets, write G equals 10 ms to the power minus 2. G equals 10 ms to the power minus 2. Your turn, work. Work, work, work. Simple questions. Online people put the answers and go. Hurry, right. There you go, equation. Hydrostatic pressure is equal to H rho G. What is the depth here? 3 meters. Density 300 kilogram per meter cube. Gravitational acceleration 10 ms to the power minus 2. What's the hydrostatic pressure? 9,000 Pascal. Okay. Interesting, no? Then we'll do one more question. Quickly write down. You all only told. Question 9. Question 9. Write down. Calculate the hydrostatic pressure. Calculate the hydrostatic pressure. Calculate the hydrostatic pressure acting on a diver. Acting on a diver. DI, dry illa. Dry never. Diver. Diver. Calculate the hydrostatic pressure acting on a diver. Diving at diving at diving at a depth of a depth of at a depth of 11.5 meters. 11.5 meters. Inside brackets, density of water 1000 kilogram per meter cube, gravitational acceleration 10 ms to the power minus 2. Density of water 1000 kilogram per meter cube, gravitational acceleration 10. Work. Interesting, no? Done. Boys, what's the answer? What's the answer? Right. There you go. Hydrostatic pressure equals H rho G. H 11.5 meters multiplied by density 1000 kilogram per meter cube multiplied by 10 ms to the power minus 2. How much? 10 into 11.5, 115, 000 Pascal. Okay. Interesting, no? My boys, you are interesting, no? Hurry, hurry. Go and come. Take 10 minutes break. We'll continue in 10 minutes. Right. We were doing question from hydrostatic pressure. 2 questions done. Write down question. No, 3 question done. No. Question 10. Question 10. A practical type question. Huh? Shh, shh, shh. Question 10. Maximum hydrostatic pressure. Maximum hydrostatic pressure. Maximum hydrostatic pressure. Maximum hydrostatic pressure. That eardrum. That eardrum. Eardrum. That eardrum. Eardrum. That eardrum can bear is 1.013 into 10 to the power 5 Pascal. 1.013 into 10 to the power 5 Pascal. Full stop, continue. Calculate the maximum depth calculate the maximum depth that a diver can dive. Wait, calculate the maximum depth that a diver can dive. A diver can dive. A diver can dive without any ear protections. Without any ear protections. Without any ear protections. Brackets, density of water 1000 kilogram per meter cube. Gravitational acceleration 10 ms to the power minus 2. Density 1000. Gravitational acceleration 10. Quickly work. Practical type question. I'll repeat the question again. Quickly write down. Maximum hydrostatic pressure. Quickly write down. Those came now. Quickly write. Maximum hydrostatic pressure that the eardrum can bear. That the eardrum can bear. That the eardrum can bear is 1.033. Sorry, 1.013 into 10 to the power 5 Pascal. Is 1.013 into 10 to the power 5 Pascal. 1.013 into 10 to the power 5 Pascal. Full stop, continue. Calculate the maximum depth. Calculate the maximum depth. Calculate the maximum depth. A diver can dive without any ear protection. A diver can dive without any ear protection. A diver can dive without any ear protection. Brackets, density of water 1000 kilogram per meter cube, gravitational acceleration 10. Voice work. Online people send the answer. Done. Done. Maximum pressure that the eardrum can bear given. Density given, G given, find H. Same equation. Shh. Hydrostatic pressure equals H rho G. What's the hydrostatic pressure? 1.013 into 10 to the power 5 Pascal equal. Maximum depth you don't know, I'll keep it as H multiplied by density 1000 kilogram per meter cube. Shh, shh, shh. Gravity 10. Shh, shh, shh. ms to the power minus 2. If I want to find H, I need to subject H. All the others go on to the other side. And tell me, multiplication on the other side become division. H is equal to 1.013 into 10 to the power 5 Pascal divided by all these things on the other side. 1000 kilogram per meter cube multiplied by 10 ms to the power minus 2. To make the calculation a bit easier, I will rearrange this. 1.013 into 10 to the power 5 divided by 1000 into 10 is 10 to the power 4. Agree? See? 1, 2, 3, 4, 0, 10 to the power 4. Height is measured in meters. Now simple calculation. 10 to the power 4, 5 cancel out. You have 1 there. Multiplied. Height is how much? Multiplied by 10. 10.13 meters. Now what does this mean? Maximum depth that a diver can go without any ear protection is what? 10.13. After that, if he tries to go, eardrum will get torn off. That's why when you do swimming, have you felt? When you go a little bit deeper in the water, you will feel ears getting blocked. Some people come out and they take the water out. They can't hear anything for a little time. That is because eardrums are pressurized. Maximum pressure that the eardrum can bear is this amount, 1.013 into 10 to the power 5 Pascal. You experience it when you go to 10.13 meters of depth. So below that, if you try to go, your eardrums will break off. So our previous diver, 11.5 meters. Fellow's ears are already gone. Maximum 10.13, this fellow 11.5. So that fellow, if he had gone without any ear protection, then gone. That's why when you buy googles, like nail-like things is there. Argadan. Not that nail. Nail-like shape is there. Hurry, those are doing, quickly finish it. 10th question. Yeah, online paper correct. I'll change. Right. Question 11. Shh, shh, shh. Question 11. Question 11. Right there. Shh, shh, shh. Question 11, write down. Consider the following. Shh. Consider the following. Consider the following. Points in the points in the points in the fish tank. Points in the fish tank. Points in the fish tank. Within brackets, right? Density of water. Density of water. Density of water. 1000 kilogram per meter cube. 1000 kilogram per meter cube. Shh, shh. 1000 kilogram per meter cube. G equal G equal 10 ms to the power minus 2. Under that, draw this. Right. Start working. Before you all work, listen. One warning. Depth is given in centimeters. Huh? So first you need to convert to C. I have not given the depth. Something else I have given. Think and do. Hurry, work. Work, work, work. Depth given in centimeters. Huh? Why Akif? Done. Akif, where's the rate? Huh? Journey. Address price. Hurry. Right. Roman 1. Shh. Hydrostatic pressure at A. Shh. Hydrostatic pressure at A. Depth of A. Density G. What is the depth of A? What's the depth? 10 centimeter. In centimeters, you can't keep it. You need to convert to meters. Most of you might tell me, sir, 0.1 meters, 0.1 meters. Decimals is hard to solve. No? I'll keep it in fraction. 10 centimeter is 10 over 100 meters. No, agree? Divided by 100, that is meters. 10 over 100 meters. Shh, shh, shh. Multiplied by density of water given 1000 kilogram per meter cube. What is G? 10 ms to the power minus 2. Now, cancel off the zeros. What's your hydrostatic pressure at A? What's the hydrostatic pressure? 1000 Pascal. Okay. Dalrin got it? Right. Question 2. Question 2, what's the answer? Hydrostatic pressure at B. We'll work it. Shh. Hydrostatic pressure at B, HP rho G. What is the depth to be? 50 centimeter. That directly tell me. 50 centimeter is how much of meters? Half a meter, no? One shot we can write half a meter. Why? Multiplied by density, 1000 kilogram per meter cube. Shh. Gravitational acceleration 10 ms to the power minus 2. From there, hydrostatic pressure at B, how much? Half of 10 is 5. 5 into 1000, how much? 5000 Pascal. Last question. Did anyone find hydrostatic pressure at sea? What is the depth you all took? How much? Darren, how much? Lamai, 20 centimeter is not the depth. It is some length below point C. Whatever they are below point C, we are not interested about. What we are interested, whatever the depth above point C. That means this depth. Total length they are 100. This length 20. So what is the depth? How much? 80 centimeter. Okay. Eighty centimeter depth is there, density is there, G is there. Work. Huh? Sure. Right. Hydrostatic pressure at sea, HC rho G. HC how much? 80 centimeter. 80 over 100 meters. Shh. Density 1000 kilogram per meter cube. Gravity 10 ms to the power minus 2. 120, 120, 18 to 1000. How much? 8000 Pascal. Okay. Any doubts from hydrostatic pressure calculation part? All clear? All clear? Sure. Hurry. Now write down a subheading. This one, anybody writing still? No. Write down a subheading. Shh. Properties of hydrostatic pressure. Properties of hydrostatic pressure. Properties of hydrostatic pressure. Right. Shh. Listen, eh? First property, listen. First property, teach it with a question. Question number 12. First property, I'll teach with a question. Question 12. Shh, shh, shh. Right there. Question 12. Calculate the hydrostatic pressure. Calculate the hydrostatic pressure at A, B, C, D. A, B, C, D. Full stop, continue. Density of liquid. Shh, shh. Density of liquid. I'll repeat again. Calculate the hydrostatic pressure at A, comma B, comma C. A, B, C, D. A, B, C, D. A, B, C, D. Inside brackets, density of liquid. Density of liquid. 1000 kilogram per meter cube. 1000 kilogram per meter cube. Shh, shh, shh. Density 1000 kilogram per meter cube. Gravitational acceleration 10 ms to the power minus 2. Gravitational acceleration 10 ms to the power minus 2. Now see, listen. 4 different shape vessels are given. All are filled with the same liquid, same again water. All their levels are same. Can you see that? All their levels are same. That means all their depth is also going to be same. I want you all to find the pressure at A, pressure at B, pressure at C, pressure at D separately. Work. Apply H rho G for each point. First draw and then work. Huh? Finish. Right, density 1000, G 10. What's the hydrostatic pressure at A? Anybody found? How much? 20 the girls? What's the value? Ah, right. Shh. Hurry. Shh. First hydrostatic pressure at A, H rho G. Shh. What's the depth there? Shh, shh, shh. What's the depth? 2 meters. Density of the liquid? 1000 kilogram per meter cube. Gravitational acceleration? 10 ms to the power minus 2. What's the hydrostatic pressure at A? How much? Louder, how much? 20,000 Pascal. Right. That's the hydrostatic pressure at A. Hydrostatic pressure at B. Again, H rho G. What's the depth there again? What's the depth? Again 2 meters, no? 2 meters. 1000 kilogram per meter cube. 10 ms to the power minus 2. What's the hydrostatic pressure at B? Again, how much? Louder, how much? 20,000 Pascal. Next, hydrostatic pressure at C. Again, H rho G. Again, tell me what's the depth? Shape is different, but still, what's the depth there? 2 meters. No change. 2 meters. Density 1000 kilogram per meter cube. Gravitational acceleration 10 ms to the power minus 2. How much? Hydrostatic pressure at C. How much? 20,000 again. Finally, hydrostatic pressure at D. H rho G. Again, what's the depth? 2 meters. Density 1000 kilogram per meter cube. Gravity 10 ms to the power minus 2. From there, what's the hydrostatic pressure at D? Again, how much? 20,000 Pascal. 20,000 Pascal. Right. What do you understand from this? What do you understand? Oh, nobody else. Nothing, sir. Even Amy, you should understand something, no? Huh? Huh. Any other? Any other? See, this tubes, their shapes are totally different. Shapes are different, but still depths are same. Then hydrostatic pressures are same. So y'all tell me, will hydrostatic pressure depend on the shape of the vessel? No, different shapes, but still same hydrostatic pressure. Shape of the vessel means actually what are we talking about? Area here. Here the area, here the area, here the area, here the area. Areas are different. Even though areas are different, is hydrostatic pressure different? No. So remember, hydrostatic pressure does not depend on the shape of the vessel and does not depend on the area of the vessel. First property of hydrostatic pressure. Again, what's the first property of hydrostatic pressure? Hydrostatic pressure does not depend on the shape of the vessel and does not depend on the area of the vessel. Again, louder. First property. Hydrostatic pressure does not depend on the shape of the vessel, does not depend on the area of the vessel. Got the point there? Right. Did you all write it and finish it off there? This part done? Under that itself, take a color pen, put a star in, right? Color pen, put a star in, right? If anyone is writing, first finish it. I'll give 1 minute, quickly write and finish it. Color pen, put a star and write. Hydrostatic pressure. Hydrostatic pressure. Hydrostatic pressure does not depend on the does not depend on the does not depend on the shape of the vessel, shape of the vessel, shape of the vessel, and area of the vessel, area of the vessel, shape of the vessel and area of the vessel. Okay, right. Second point, listen. Shh. Second property, listen very carefully. Shh, shh, shh. Lamai, hydrostatic pressure, listen, hydrostatic pressure, there you go. At a given point, listen very carefully, hydrostatic pressure at a given point acts in all the direction. There you go. The pressure here will act downwards as well as act upwards as well as act sideways. There you go. Hydrostatic pressure at a given point acts in all the direction. So in all the direction you have the hydrostatic pressure acting. Don't only think 2D, think 3D. 3D ways around in a spherical way, every side hydrostatic pressure will act. So hydrostatic pressure at a given point acts in all the direction. Think 3D. Huh? Don't think 2D. Now north, south, east, west, way, front, back, every side. So in all the direction, hydrostatic pressure will be acting. Got the point there? Right. Write down. No need to put number 2. Just put a star in. This is the second property. Put a star. Color pen, color pen, color pen. Hydrostatic pressure. Hydrostatic pressure. Hydrostatic pressure. At a given point. At a given point. At a given point. Acts in all the direction. Acts in all the direction. Acts in all the direction. Quick. Yeah, draw this. Okay. Right. Shh. We have a small activity to prove this. Listen, eh? We have a small activity to prove this. What's the activity? You take a polythene bag, shopping bag, you take a shopping bag, not a polythene bag. Fill it with water. Shh. Now this is not a mutti. It's a bag, balloon. Hariyanne. A little bit of a stronger one. Polythene bag, not a shopping bag. You fill it with water. Shh, shh, shh. You fill it with water. When you were small, you would have done this. Take a small pin, put holes in all the places. When you put holes, listen, water starts pouring out in all the direction. Have you all done it? Water starts pouring out in all the direction. Now don't go home and do. Your mother will think, Amma say grade 10, grade 6, okay, Chuti kale, you would have done this. Take a bag, you fill water, put holes in all the sides. From all the sides, water is sprayed out. Why? Because pressure is pushing the water from all the direction. Got the point there? So pressure, hydrostatic pressure at a given point acts in all the direction. Think 3D, not only sideways, all the sides you put holes, from all the sides water will be sprinkling outward. Got it? Understood the point there? Right. Under that property, write down activity. Activity. Take a bag. Take a polythene bag. Take a polythene bag. Take a polythene bag. And fill it with water. Take a polythene bag and fill it with water. And put some holes in. And put some holes in. Put some holes in all the sides. All the sides. Full stop, continue. Water will be sprayed out from all the direction. From all the direction. Quickly draw this balloon thing. Balloon, never me. Balloon wala you can't do, no. When you put a hole, that fellow will burst and go. No? But in a balloon, you can't do. Okay. Right. Up to now, What we did? Again, revision. We started with pressure. What is pressure? Force acting in a unit area. What's the equation? Pressure equals perpendicular force divided by area. What's the unit? Nm to the power minus 2. That is also called as Pascal. Right. Y'all tell me. When area increase, pressure decrease. When area decrease, pressure increase. Next. Force increase, pressure increase. Force decrease, pressure decrease. That's it. That pressure concept. Shh. What is hydrostatic pressure? Pressure acting in a fluid. Pressure acting in a fluid. What's the equation? H rho G. What is H? Depth there. Rho is density. G is gravitational acceleration. Shh, shh, shh. When depth increases, hydrostatic pressure will also increase. When depth decreases, hydrostatic pressure will also decrease. What's the first property under hydrostatic pressure? Hydrostatic pressure does not depend on the shape of the vessel and area of the vessel. Second property, hydrostatic pressure at a given point acts in all the direction. Understood up to there? Hurry. Next week onwards, we'll continue from that point. Next week, few more properties are there and we'll be starting YouTube problem. YouTube questions are there. U-shaped tube. Then we'll meet again next week. Get home safe.